Swayam Prabha. Digital India. Educated India.
Hello everybody, welcome to the NPTEL online course on structural systems in architecture. So, we are now on the lecture number 29, week number 6. In lecture number 29, we will have the topic of discussion is on the application of arch and shell in architecture. The concept cover will be there will be 4 such concepts, that thrust line application and the application of the arch in architecture and the application of the shell in architecture, and finally some kind of design exercise with shell structure will do. The learning objective of this particular lecture will be we will see the application of shell and arch in architecture, different buildings in the architecture and how it has been used, and we will try to design some of the conceptualized some of the design for the shell for a given space. So, if you remember in the last lecture, in fact last to last lecture we discussed the thrust line on arch. The arch, because of the Y-shapes, they are inclined in nature and they are wedge in shape, they are having some kind of actions, force actions due to the own weight and the lateral horizontal reactions. This gives the resultant as a thrust line. So, if this thrust line is goes beyond the incline, it is such a incline that is goes beyond the support, then definitely the system become very much unstable and there is a failure in that system. So, arch may fail or maybe the pedestal may fail. Whereas, in that case, what are the solutions involved? In the solution, if you see, there are 2 alternatives involved in that particular solution. One, we can go wider. So, initially in the previous, if you see, it was thinner, very thin support, but here you see it is wider, it has is much wider. So, much wider, why? Because the much wider will take care of this particular load, the thrust line load. So, I can have the much wider piers, and then that can be taken into account and the stability will come. There is another way we can do it, that we can additional gravity load we can put in the above the arch and very near to the pier. So, this additional load will, which was actually this thrust line was like this. Now, due to the additional load, this particular thrust line is like a reaction line. So, now if the downward direction is high, so it will try to take the thrust line back to the normal or back to the vertical line. So, that is also can be done. So, we will see that how these two are actually going to have these 2 principles, particularly these 2 principles by a small video. So, if you see this particular video, you will see that there are some blocks and there is inclined actions, load actions, but if you increase the thickness, then it is going to tough to fall. I mean, this is going to tough to fall, and if you put some vertical loading, then it is further tough to fall that particular this thing, the system. So, here we can actually going to have that particular kind of additional load, or maybe the widen of the wider pillar to rescue the system. Now, let us go to the little bit of the history of architecture, how this particular principle is applied in the Gothic arch. In the right hand side, you will see this is the Gothic arch, and suppose this is the kind of a arch, and this arch gives you some kind of the reactions, and those reactions are of in nature and inclined in nature, and due to that reactions we introduce the flying buttresses. So, here in this particular area there is a kind of inclined forces will be generated, and these forces will be generated, and then that force can be taken into account. Otherwise, we can do one thing in that historical area, we can put some kind of a pinnacle, that is additional load in the top, which load increases this particular horizontal reaction, and then horizontal reaction, increment of the horizontal reaction keep the thrust within that particular pair or whatever. So, the stability can come. So, now let us see some of the application of the arch in architecture. This is the first example. I have taken it from some website, and I have described this particular this is a stadium. This is a Calgary in Canada, Saddle Dome. In that you see there is a hyperbolic paraboloid, which is in the roof line. If you see the roof line, whole roof line is a hyperbolic paraboloid. It has a central dip which is almost 14 meter below the highest point. So, this particular level is almost about the 14 meter of the highest point, and the edge rings are almost about the 6 meter lower than the edge lower point or so. So, finally, if you compare the central point and those points, they are in differential height, and those differential heights are taken care of by some kind of a saddle kind of a hyperbolic kind of a paraboloid roof structure to cover the roof. Next, we see the Kunming Airport, China. This Kunming Airport, China is recently constructed, and if you go to that particular airport, you will see the whole airport is the roof of the airport is suspended like this, a lightweight kind of a thing and suspended. And if you see from the front, this thing, it's like a pagoda. It is merged with the historical character of the Chinese architecture, which is a pagoda style. But if you go inside that and you say that, you will see that this particular pagoda style of roof is supported by a series of arches, and those arches are of different span and different curvilinear in nature. I mean, this is all are of parabolic kind of arches. You see one arches are flying from the bottom to the topmost. This is the main arch, and this is a subsidiary kind of a arch or strengthening kind of a arch which is moving along with the topmost part, and there is a junction between the subsidiary or the secondary the arch with the primary arch also, and it makes the interior so interesting, visually so interesting and so pleasant that sometimes we may feel that this particular design is a kind of a design which is merged with the interior and merged with the principles of the Chinese architecture or the Chinese philosophy, but if you see minutely, it is actually a kind of a structural systems which merge with that particular the building form also. The next one is the Renzo Piano's one of the masterpiece, which is a church in Italy, and in that you also see very similar to that the Kunming Airport, where in this church a very lightweight roof member is designed or is constructed, and that lightweight roof member is supported by series of arches and intersecting kind of arches, and then those arches are segmental arch is the case of a primary support, which are flying various points in this particular inside the church, and how this load has been taken into account is by some kind of a steel tripod. You will also see in the elevation, the front this figure, there are some steel tripod which are connecting which are the structural connection between your roof and the arch. So, that gives a kind of a loading to the arch, some typical point there are loading to the arch, and that arch is now the distributing or the transmitting that load to the foundations also. very interesting in that sense that interior, if you fly with arches, these two, the Kunming and this particular Italy church in Italy, are very similar in that nature, that arch interior is predominantly used as a visual element, and its the massivities and all are gives you a kind of a and geometric massivity gives you some kind of a feeling inside that you are in a kind of a place, huge arches, and but that is very tactically used as a structural member. Another example of the arch is the Athens Olympic Airport, which was constructed in 2004 by the master architect Santiago Calatrava, a Spanish architect who is actually more of engineer kind of a engineer kind of an architect, who is whose all the designs are imparted some kind of the mechanics or the engineering phenomena in the in reality through architecture, a piece of architecture. So, in this is a very simple stadium which was constructed for it was there, and the new roof was constructed, and the new roof was reconstructed as a bent leaves, two bent leaves, and which has some kind of a property which will generate some kind 90% of the light, sunlight and all those. But other than that, the roof is actually supported by two double layer the arch, parabolic arch, this two double layer parabolic arch. I mean this is one, this is another one, and this is the connection point. So, this parabolic arch are of almost 300 meter span, and of course, about the 60 meter of the height. So, that two giant arches are taking care of all. And if you see the next figure, you will see some other angle. So, this figure gives you a lot of interesting phenomena, that one arch or the arches are gradually, the thickness of the arches is increased, because it has to take care of the lot of reactions in the end and the thrust. It has been anchored as a mega column kind of a thing in the ground. It has some kind of a diagonal bracings from that too to take care of your the thrust action, and the whole roof structure was suspended by wires, I mean the suspension cables and all, which we will discuss in the next lecture, the week number 7. There are some typical suspension cable in the both in some inclined direction and the vertical directions also. So, how interestingly that particular design has been done. It is look like these two arches and this inclined bracings and the suspension cables are a part of the system. But if you see, look at into the proportion of that, the way it has been designed and all, it goes along with the part of the architectural design, but it has a enormous role to play as a structural member also. So, where that these two are actually come into the play, I mean the innovative structural systems with the that creating a kind of architectural element to a particular design also. Let us go to the another example of the shell. Now, it is some example of the application of the cell structure in the architecture. So, a brain station which is also in Italy. So, if you see the interior view, the series of steel arches are created to take care of the roof, and those beams are, if you see, it is some the hollow or some perforations in the wave, which is also called, we have already talked about that is called the castellated beam, which is having a kind of a structural advantage. But these beams are in elliptical in nature. If you see, this is almost like a part of a elliptical nature. So, they have used the elliptical series of elliptical arches. Now, in the next figure, we will see that how this elliptical arches has been taken care of, or the shell has been taken care of. So, elliptical ribs, those are called ribs, used as a long supporting kind of a thing member, and that is going to transfer the load to a pre-stressed the pre-stressed block. So, this number 2 is your pre-stressed block, number 1 is your rib, and this pre-stressed deck floor will going to have a below there is a girder. So, this is the girder which is number 3. So, this is going through like this, and this girder supports another thing, that is the railway track. This is the railway track over here, which is supported by the girder, and finally that girder, which is taking care of the roof load and those deck load, finally is supported by the columns, which is not visible from this particular right hand side picture also. So, how it is not a a kind of a one kind of a system, it has 3-4 systems like acting together, but the predominant visual elements is the topmost elliptical series of arch which create a shell. The next example, again there is a station which is in Spain. So, how the parabolic arch and the shells has been used in that station, I have explained through this particular figure and some notations. So, it has four typical things to be noted. So, the first one is the parabolic arch, which is a slick kind of a arch, which is this, or in a series it has been laid down. And then this second one is a funicular form minimize the bending action, and the form is the funicular kind of a form which going to minimize. It is a reverse form of a cable which is sagging by its own weight. The third one is this, that the arches are suspended by a deep beam, supported by, not suspended, sorry, it is supported by the deep beam. This is a deep beam which is running from one column to another column, and arches are actually fall into that, and they are transferring the load to the deep beam as a pointed load also. And fourth one is are the circular columns which are provided it is certain separations one after one, because in the railway station you should not have very much of obstruction columns and all. There should be a long span kind of a there should be the footprint of the structural things has to be long span, otherwise the movement of the people and luggage and the goods has to be disrupted. So, we need a high span. So, a arch has taken care of with a deep beam has been transferred to the load to the particular columns, serial columns or so, can create a wonderful system of the structural systems with the shell. Another example is in the art and science the museum, the gallery in Valencia, Spain. It is also designed by the Calatrava. Umbraskel, it is almost 17,500 square meter of the sky garden kind of a thing, which was supported by the series of lightweight arches, and which create a kind of a shell, in a lightweight kind of a see-through kind of a cell with the lightweight metallic members, and there are elevated deck, landscape deck on it. If you go to the another view, it is very much interesting to see that this is the steel arches, and the steel arches are in a kind of a three-dimensional truss kind of a thing. And if you see the one from this point, this flies like this, and from this point this flies. So, it create a kind of a folds, and each arches are connected by some steel member or the lightweight steel member, which also create a total the pattern of the surface in that in a undulated manner. And this particular landscape garden was actually elevated by a landscape deck, RCC landscape deck, and then as you know that this RCC landscape deck has to take a lot of load because of the trees and all those kind of the dead load and the live load also. And this has been taken by inclined column in each interval, and also in the other side, and this inclined columns of the supports the deck in the effective cover area of the each column is increased by tree like branching. So, that also we have discussed. So, the influence area of these columns are increased by this tree like the capital increment also. So, there are actually inclined column finally gives a load from this point, but it is taking load from 1, 2, 3, 4 points actually. So, in creating it the influence, increasing the influence area. Another example of the Bilbao airport, Spain, again designed by Santiago Calatrava, which is usually with a two shell which is intersecting in a different level, and as and when it is intersecting in a different level here and also at this particular point, you will get a kind of a clear story effect. So, if the two shells are intersecting in a different level, so you can get a clear story, and in that clear story you can have the ample amount of light. You can see in the right hand side photograph how much daylight is actually entering to that particular airport, and it is quite enough. I mean, if you have this particular clear story in the northern side, you can allow some kind of a diffused lighting over there, and those are transfer ribs or transfer post, which transfer the load of the upper shell to the lower shell or so, and there are definitely some peripheral supporting member in some strategic locations also. And the aerodynamics nature of that particular the build form gives a kind of a indication that this is the airport. This visually it's look like something is flying, something is taking off, and something is moving or lifting away from one upward side. So the nickname of this particular airport is the Dome. So it goes with the form of this particular airport, is goes with the function of it, and visually it's should it look like it's something like a airport only because of the kind of a aerodynamic nature of this particular form. And by virtue of that he has created the shells, designed the shells, and the shell has been taken into the action like the thrust and all these things has been taken into account by the engineers. Another example, that is another auditorium in Spain. So in that auditorium there are various levels of the platforms are actually wrapped by the shells, which is one is the mega one, which is at the topmost part, which is a freestanding shell, which is very interesting. I mean the freestanding, see there is only the ground support in only some part, and other part is actually hanging like a cantilever, and this is taken care of by this again 2 or 3 kind of a split shells which are cupola, and inside cupola there are various levels and the various activities are going on, as it's the auditoriums also, there are multi deck also. So the next figure if you see, and this another interesting thing is that this particular, it is opera house, it is a part of the opera house and the science and art museum. Some part is submerged to this is a water body, it is a water body, and the part of the planetarium is half sunken to in the globe. I mean that globe is half sunken, and if you see the section, of that, you can have this entrance portion, and from the entrance portion you go to the various level of various activities, and finally this is covered by the metal sections and the metal section screen dome, and the upper layer of this particular portion is supported by some inclined columns. So this is the inclined column, and symmetrically it is supported by the inclined column also. So next we will go to some kind of a design exercise, and let us see how that can be dealt with. But this design exercise is whatever I will tell you now, it is my view. You can have your different views also, or maybe you can improvise your thought for that. Suppose I have a rectangular space, which space has to be covered with some roof, and I am thinking of something like a shell, because how to do that. So this roof, maybe there are many ways we can do. Suppose if we go with a kind of a series of partition this particular portions, so each we can think of some kind of a barrel vault. That is very simple. So if barrel vault are like this, it is cylindrical kind of a one directional shell, which will be kind of series in nature, but this will be definitely going to give you a very monotonous kind of a look. So how can you improvise that one? We can improvise that one in a different way. So we can have some this partition in a like this probably. I mean this partitions is not equal partitions. So this is smaller span and this is larger span. So now if you go with this barrel vault same, so this will be the dia of the vault, and this will be the dia of the next vault. So you can have some kind of a rhythmic play. So there is some changes instead of going with the same span or whatever this thing, we can have some kind of a rhythmic change. Now there can be some more improvisation. Some more improvisation is that suppose you are you are going to create a kind of maybe some kind of some sector like this. So I am distributing or dividing this particular space into 4 or 6 equal square space or equal space. May not be square, it may be a kind of a square, and these 4 points is portion is one module. I will repeat the module into the. So, in this 4 point, the height of the 4 columns will be, I will make some change, I mean I will have some differential height. So, maybe this is higher, this is the lower, and this is having some kind of differential height. So, suppose this is 4 meter, this is 3 meter, and this is suppose your 1 meter or so. Now, if you just go for a ruled surface, so you will get a kind of a surface like this on that. So, you will get a some kind of a hyperaboloid kind of a parabolic hyperaboloid kind of a space, and we can have that particular in here. So, you can repeat that with that particular module, you can change, rotate and repeat. So, there may be a inclination towards this, and there are top the highest point in this. So, like that we may change, and your elevation may look something like this, which will and something also may be visible from the behind also, something, because that is lifted up also. So, we can have those kind of process which that kind of the roof structure design also. Sometimes we may think of some. So, those kind of the partitions, this kind of the partitions or the shell or those kind of the hyperaboloid kind of a formation can be easily done. Suppose you are going to actually park some vehicle, so parking lot. So, parking lot you need to have some just top cover, you may not require some kind of the peripheral wall. So, we can think of some solutions like this. It may have a kind of a metallic the ruled surface kind of a thing. Concrete will be little bit difficult, but still some of the architects has used, engineers has used those kind of a thing with concrete. So, the steel can be used, and some kind of a creepers can be actually go along with this. Some creepers can be go along with this. That will be a very natural look, and it can give some kind of a shade. You can think of some kind of a area which is supposed to be a service area. Suppose you are hosting some pump room, some kind of the AC plant or something like that. So, in a some part of your site which may be neglected from one point of time, that it is neglected, it is not going with some kind of merging with that the form of the particular building. You make it interesting. To make it interesting, we can go with some kind of a simple shell structure or so. Another formation, suppose we instead of going with the barrel vault, we can go with the convoid. So, here we can partition this particular into this module, or maybe in this circular case, suppose some the auditorium or something with this module, and we can have some kind of the different system of this is can be a kind of a bus stand. There are the circulation area, people circulation area, and there are some buses are there, in the base of buses are there. So, we can have very interesting kind of formulations by convoids also. So, we can have two such examples. One is the Sydney Opera House 1973. You see, this is the plan where there are mostly two such big auditorium, and these auditoriums are actually going to covered by the shell. Just it is a plain auditorium, I mean plain in the sense is a flat auditorium in different level, and that is shell, and these red color shells are in the one sided shell, this, and these are the other side. This the yellowish color is in the other side. Another interesting the shell structure is there in the Lotus Temple Delhi. So, if you see the Lotus Temple Delhi, so this is the plan of that, this rose like or the flower like, this thing is the plan, and I have mentioned the 3 different color showing the 3 different type of shell. One is this, these are the initial peripheral, 2 is this, so that is the 2, and the third one is this, the inner core. So, these shells, this is the 1, 2 and this is the 3. So, these 3 shells are placed such a way, construction is a difficulty definitely, but it is creating a very kind of interesting kind of a scenario. So, in the reference I have used these books for this, basically for some of the books I am taking for some photographs and help, and You can also go through that. So, in conclusion, we may say that this arch is a very elementary element for the structural systems we have seen last 3-4 lectures. It is widely used in the cathedrals, also in the modern buildings, and in the contemporary architecture, shell structure is used in many occasions and in different buildings. So, I have some homework for you. I have developed plan, the layout plan. Suppose this layout plan for a kind of a hall complex, lecture hall complex, or some kind of auditorium hall complex. Dimensions are not that much important over here. So, there are 1, 2, 3, this is in this case 1, 2, 3 this auditoriums are there, and there are, this is the entry, this is another layout, squarish kind of a thing, is circular. So, what you have to do, you have to find a kind of solution and sketch the schematic plan elevation section using shell roof. How to cover this thing? Suppose there are, you have to also put some kind of a footprint, that this will be my proposed footprint or something like that, and how it will look like, what will be the how the shell will be there, is it like this or it is like this. So, that you have to think, and then finally you have to draw some schematic plan elevations or sections. And this, as it is a kind of the exercise that you can develop, and there will be n number of solutions, and you can think of some kind of application in that. Thank you for this lecture, listening this lecture number 29. So, in the next we will go for the last part of the shell and dome, arch, shell and dome.